Here's a number that should bother anyone paying an AI bill. A huge slice of the questions you send to a giant frontier model don't need a giant frontier model. Reformat this list. What's the capital of France? Fix this typo. You're paying premium rates for a supercomputer to do a job a much cheaper model would nail instantly. An LLM router is the fix. It looks at each request and decides which model should actually answer it. Let's break down how it works. Start with the trade-off every AI app is quietly fighting. The simplest strategy is to send everything to the biggest, smartest model you have. Quality is great, and you never worry about picking wrong. But you pay top dollar on every single call, and the big model tends to be slower too, even when the question was trivial. A router flips that default. Instead of one model for everything, it matches each query to the cheapest model that can actually handle it. Easy questions go somewhere small and fast, hard ones still get the heavy hitter, and your average cost per request drops a lot. The reasoning behind it is simple. Frontier models are powerful but pricey and slower, small models are cheap and quick, and most requests genuinely don't need the biggest brain in the building. So how does a router actually make that call in real time for every request? Follow one query through it. A query arrives at your application. Before it touches any expensive model, it hits the router first. Think of the router as a smart receptionist sitting in front of your whole model lineup, deciding where each request should go. Then the router estimates difficulty. Maybe a tiny classifier trained on past queries, maybe some heuristics, maybe even a small model doing a quick judgment. The goal is cheap and fast. Whatever it uses has to cost far less than the model it's protecting. Based on that estimate, it routes. Easy prompts go to a small, cheap, fast model. The genuinely hard ones get escalated to the big, expensive model. Some routers even cascade, trying the cheap model first and only escalating when its answer looks shaky. And the answer comes back to the user, who never sees any of this happen. Done well, you capture most of the quality of always using the big model while spending a fraction of what that would have cost. Let's distill a router down to the 3 ideas that actually make it work. First, classification. Every request gets its difficulty estimated up front, cheaply and quickly. That single judgment is the engine of the whole system, so the classifier itself has to be small and reliable. Second, matching. Easy queries flow to a small, cheap model, and hard ones flow to a strong, expensive one. Some setups also route by specialty, sending code to a coding model, or cascade upward only when a cheap answer looks weak. Third, the payoff. Studies show routers cut costs dramatically while giving up very little quality, which is why they sit alongside caching and prompt optimization as a core trick for building affordable AI applications. There is a catch worth naming. The router itself adds a little latency and can occasionally misroute, so its classifier has to be both accurate and cheap to be worth having at all. Alright, let's lock in the essentials on LLM routers. A router is a production system that decides, for every incoming request, which model should answer it, balancing cost, latency, and quality. It classifies each query's difficulty, then sends easy ones to a small cheap model and hard ones to a big expensive one. Done well, that captures most of the quality of the biggest model at a fraction of the cost, though the router adds a little latency and can misroute. Routing ranks among the highest leverage tricks for shipping affordable AI, so it's worth understanding well. Want more explainers exactly like this one? Everything lives over at Standarity.com. Catch you in the next one.